In this video, we will see dry run of the code. Now let's quickly check the code dry run of this code. Okay, not the code implementation. So basically we have one stack. So this is my stack. Okay, we have one answer. So this is my answer array. Right. So stack is done, answer is done. So I will start from 0. I will start from 0. This 10. Okay. While stack dot length is not equals to 0. So stack is basically 0 here. So I won't come under this while loop. I will directly come here. I will say yes, stack length is 0. So whatever the index is 0 plus 1 will be my answer. So answer I will be 1 here, right? If condition is true, I will simply the stack dot push I. So I will push 0 here, right? Once I am pushing it, again I will do I plus plus, I pointer will be here. Okay, this is my I pointer. Now again I will check, is my stack dot length is not equals to 0? Yes, it is not equals to 0. And your stack peak element, basically this is my stack peak element, right? So stack peak array of peak. So array of 0, that is 10. Okay, is 10 is lesser than equals to array I? Yes, it is. It is lesser than. So simply remove stack dot pop. So I will remove. Now is your stack dot length is 0? Yes, it is. I will come here and my length is 0. So I will do I plus 1, 1 plus 1. That means it will be 2. Again, I pointer will move here, right? And before moving, stack dot push I. So I will simply push 1 here. Now, what I will do, I will again check, is my stack dot length is not equals to 0? Yes, it is not equals to 0. So array of stack peak element. So array of stack peak, that is 1. Array of 1, that is 100. Is 100 is lesser than equals to array I, that is 20. It is not lesser than, it is greater than. So I will come out from the while loop. I will say, is your stack length is 0? No, it is not. So else, that is the case of I minus stack of stack dot length minus 1. So I minus I is pointing to 2, 2 minus of 2 minus 1. So that will be 1 only. Then my I pointer will be move ahead, and before moving stack dot push I. So I will push 2. Now I will check, is my stack length is not equals to 0? Yes, it is not equals to 0. And my array of stack, so array of 2, that is 20, is lesser than equals to array I. That means 25. Yes, it is. So simply pop it out. I will do stack dot pop. Now again, stack length is not 0, and array of peak, array of 1 is lesser than. No, it is not lesser than. I will directly come to if condition, stack length is 0. No, I will come to else I minus 1. So I is 3, 3 minus 1, that means it will be 2, right? So again my I pointer will move here. Now before moving again, I will push the ith index, that is 3, right? Now I will check for 30, right? Stack length is not 0. Okay. Array of 3, that is 25, is lesser than equals to array I. Yes, it is. So what I will do, I will do stack dot pop. I will remove it. And I will say, right, again I will check, is array of stack, that is 1, array of 1, that is 100, is lesser than equals to array I 30. No, it is not. So I will come out from the loop. If condition won't be true, else condition I will come, because else because stack is not 0. So I will say I minus stack dot length. So I minus 4, that means I minus 1. So what is I? 4, 4 minus 1, that means it will be 3, right? So in all the 3 days, 30, 25, 20, stack price is, this is stock price is lesser than equals to 30. Now I will move ahead, right? And before moving, I will put the index 4 here. Again, I will check, is my stack length is not equals to 0? Yes, it is not. Array of peak, array of 4 is lesser than equals to array I. Yes, it is lesser than equals to 40. So simply pop out. I will pop this out, right? Again, I will check, is my stack length is 0? No, it is not. So I will come here. If array of 1 is lesser than equals to array I. So no, array of 1 is 100, which is not lesser than. I will come here. I will check stack length is not 0. Okay. So I will come to else condition and I will say I minus of 1. So 5 minus 1, that will be 4, right? Then before moving, I will simply push 5 here, because that index, and I will come here. Now, is your stack length is not equals to 0? So yes, it is not equals to 0. Array of peak, array of 5, that is 40. Is it lesser than equals to array I? No, it is greater than. So I will come out from while loop. I will check, is my stack length is 0? No, it is not. So else case, I minus of peak element. So I minus of 5. So 6 minus 5, that will be 1. And before moving, stack dot push I. So I will push 6. right? And my I pointer will move here. I will check again, right? Stack length is not equals to 0. Yes, it is not 0. And array of peak, array of 6 is lesser than equals to array I. So array of 6 will be 35, which is not lesser than, greater than. So I will come here after the while loop. I will come, is your stack length is 0? No, it is not. I will come to else condition, I minus of peak, 7 minus 6, that will be 1, right? And I plus plus, and here I reach to the end. That's the end of the for loop. Okay. And now we have, we simply return my answer, and my answer basically this. Now, what will be the time complexity here? Now, let's quickly see. This loop will run for n times, right? But will this while loop will run for n times? It can only run for n times when in a strong, basically when all the elements are lesser, right? And the last one to check for this one. So it will only run for n times for that case, right? So it will also run for single times if it is running. So n times for this one, or maybe this will run for n times. So n plus n, the worst case can be 2n, right? But is not going to be an n square. And if it is 2n in the worst case, I can say that again it is an order of n. So the time complexity will be order of n only. And what about the space complexity? Yes. Are you taking any extra space? Yes, I am taking an extra space, that is stack, and that can lead to the all elements, right? I can fill stack with all the elements, all the element indexes. So that can also be big O of n, order of n. So time complexity, order of n, space complexity, order of n. So from in approach 1, we were having some time complexity and we reached to approach 2. So if I talk about time complexity, there was big O of n square, and from n square we are reaching to time complexity of big O of n. Space complexity was big O of 1, and we are reaching to space complexity of big O of n, right? So we have decreased the time complexity, but we have increased the space. That's the trade-off, right? Whenever you are finding a better solution, you need to lose some things, and that was the space that we have lost. Okay. So that's all for this problem. I hope you enjoyed this problem. And I hope by taking this problem into consideration, that indexes, how you can play with the indexes in stack, how you can solve a good variety of problems that are dependent on the indexes. Okay. Thank you. That's all for the today's video. See you in the next video.